Hello guys, you're welcome to Vince Tech class. And in today's presentation, I'm going to walk you through feature selection techniques in machine learning. Now, in machine learning, feature selection plays a crucial role in improving model performance, reducing computational costs, and enhancing model interpretability. Now, in this presentation, we will explore various feature selection techniques used to identify the most relevant and informative features in a dataset. Now, why is feature selection important? Machine learning models can suffer from the cause of dimensionality, where the presence of irrelevant or redundant features negatively impacts model performance. Feature selection helps in reducing overfitting and also improve the model generalization on unseen data. And it also enhances model interpretability by focusing on the most critical features, making it easier to understand model's decision. Now, types of feature selection. There are three main types of feature selection techniques. One, we have the filter methods, we have the wrapper methods, and we have the embedded methods. Now, let's take the first one, filter methods. Filter methods rank features based on statistical metrics like correlation, variance, or mutual information. Now, these methods are computationally efficient and can be applied before model training. Examples include Pearson correlation, T-square tests, information gain, and variance threshold. Now, let's take the second one, wrapper methods. Wrapper methods use the predictive performance of a specific machine learning model to evaluate subset of features. They involve training and evaluating the model multiple times without with different feature subsets. Examples include recursive feature elimination and sequential feature selection. Now let's take the last one, embedded methods. Embedded methods, they incorporate feature selection as part of the model training process. They're using built-in feature selection algorithm within the model itself. Examples include LASSO, which is an acronym for least absolute shrinkage and a selection operator, and the ridge regression. Now let's take the first one, filter methods. Examples of filter methods include Pearson correlation, T-square test, information gain, and variance threshold. Now let's take the first one, Pearson correlation. Pearson correlation measures the linear correlation between two continuous variables. It ranges from -1 to 1. -1 indicates a perfect negative correlation, and 1 indicates a perfect positive correlation, and 0 indicates no correlation. And also, it is commonly used for feature selection in regression tasks. Now, let's take the second one, T-square test. T-square test determines the independence between categorical variables. It is useful for classification tasks with categorical features. A higher T-square value suggests a higher dependency between the feature and the target. Next one is information gain. Information gain measures the reduction in entropy brought by a feature to a dataset, and is commonly used in decision trees and other tree-based algorithms. And the last one is variance threshold. Variance threshold removes low variance features that contain little information, and it also helps to eliminate constant or near constant features. Next one is wrapper methods. And wrapper methods includes recursive feature elimination and sequential feature selection. Now let's take the first one, recursive feature elimination. Recursive feature elimination removes the least important feature based on model performance. It repeatedly fits the models, removes the least significant features, and continues until the desired number of features is reached. We also see the sequential feature selection. Sequential feature selection add one feature at a time based on model performance until a stopping criterion is met. Let's see the last one, embedded methods. Embedded methods includes lasso, that is list absolute shrinkage and selection operator, and ridge regression. Now let's take the first one, lasso. Lasso combines feature selection and regularization to improve model performance and induce sparsity. It also adds a penalty term to the loss function, encouraging less important features coefficient to be exactly 0. And for ridge regression, which is similar to lasso regression, but it uses LU2 regularization instead of LU1 regularization. It also helps in reducing multi-coronality and stabilizes the model. That's all for feature selection techniques. Now let's see the best practices in feature selection. The best practices in feature selection includes 1. Choose the right feature selection method based on your data set and problem type. And also consider using a combination of filter methods, wrapper methods, and also embedded methods for comprehensive feature selection. And also always perform feature scaling before applying certain feature selection. Though in my own case, I didn't apply this feature selection in my previous videos, but in my subsequent videos, I'm going to be applying this feature selection so that I will show you how it works. And finally, always validate the selected feature performance on a separate test dataset to ensure generalization. Conclusion. Feature selection is a critical step in machine learning pipeline to improve model performance and interpretability. And also, different selection techniques offer unique advantages and also should be chosen based on specific problem and dataset characteristics. Now, by selecting the most relevant features, we can build more efficient and accurate machine learning models. So guys, that's all for today's presentation. In my next and subsequent video, we're going to be seeing their implementation in Python using the Jupyter Notebook. So guys, if you have any question, leave them in the comment section below, and don't forget to like and subscribe to my YouTube channel for more content like this. Thank you.